Hi everyone. The question says a slingshot can project a pebble at a speed as high as 38 meters per second. Write down the given information. The initial velocity is 38 meters per second. Now the question says if air resistance can be ignored, how high would a pebble launched at this speed rise if projected straight up? How high would the pebble go, right? So write down the given information. The initial speed is 38 meters per second. The object is moving in a single dimension. It is projected upward. So you are expecting the object to go up, correct? It will ultimately reach the maximum height where the velocity will be 0. And now the question is asking you, what is this length? How high is this object going to reach if the initial velocity is 38 meters per second? How high would the object reach? Now, since we have one-dimensional motion, just write down the equations corresponding to 1D motion. If we are saying how high, we are talking about displacement, right? So the displacement is going to be delta x and delta x. So either equation number 2 or 3 is going to be applicable. Since equation number 3 has the time inside, we don't want to deal with that, so we're going to choose equation number 2. So tell me, what is the initial velocity? The initial velocity in my case is 38 meters per second. Yes? Tell me, at the maximum height, what is the final velocity? The final velocity is going to be 0. The acceleration is acceleration due to gravity. Since the vector is pointing down, you're just going to put a negative sign. And then you solve for delta x, everybody. I'm not going to do this step. You should do it because I already have my answer here. 73.7 meters. So once again, you're going to use the equation that I have placed here. Go ahead, plug in your values. Now, part B is asking you how long would the pebble be in the air? How long would the pebble be in the air? I'm assuming the question is asking you when it says how long, it's referring to the time that it takes to reach the maximum height and then return back down. That this is how we say how long is it in air. So where do you start? Now we are talking about time. If we are talking about time, you have equation number 1 and you have equation number 3. Take a look at equation number 3. Equation number 3 has delta x equal to VIT plus 1/2 AT squared. What do we know about delta x, everybody? Where does the object start? The object starts at some chosen reference point, right? It's launched upward. It's going to reach the top and then return back down. So when we say delta x, x sub f minus x sub I. What is the final position? 0. What is the initial position? 0. Go ahead, plug in your values, write down the initial velocity, write down the acceleration, you have 1/2, and then you solve for the time. When you solve for the time, in my case, I'm going to have 7.76, and you get the idea. Now, let's just go ahead and insert the numbers here. I want to show you something. We have 38 times t minus 1/2, 9.80. Where did the negative come from? I just pulled out the negative sign from 9.8. And then you have t squared. What do you do with the t's here? You pull out the t, factor it out, 38. The t is gone, minus 1/2, 9.80, and then another t equal to 0. Now you have two products here. You have t and then you have the rest of basically the second term. What does it mean? When you multiply these two terms, you should have 0. What's the only way to have 0? Either t is equal to 0 or this entire term is equal to 0. So now you have to set yourself the condition either t is equal to 0, which is correct, right? You are launching the object at t equal to 0. And then by the time the object comes back down, You have to solve for the time. Once again, 9.80 t. Solve for your variable time, and then you will get the, here is supposed to be 0. Just rewrite the equation down. Okay? And then you solve for your time. Okay, that's the end of question number 1. Let's move on to question number 2 now. Question number 2 says, a ball is thrown directly downward with an initial speed of 8.45 meters per second. 8.45 meters per second downward from a height of 30.4 meters. After what time interval does it strike the ground? Write down your given information. We are given the initial speed or the velocity. I told you the speed and the velocity will be used synonymously. And the fact that we're saying it's going downward, the velocity has to be negative. The height, the initial position in the vertical direction, you can either call that x sub I or y sub I because we're referring to vertical direction, 30.4 meters. After what time interval does it strike the ground? Always give yourself a sketch, everybody. Your initial position 38, your final position is 0. Because some things are going to clear up when you put that down. You have 30.4, and then you have 0. What are we solving for? The time interval. So tell me, which of these equations is applicable? We're solving for time. We know the initial velocity, and we know the distance traveled, correct? So, basically, we know the displacement. So you're going to use equation number 3. Pull it down and write it explicitly. Delta x is x sub final minus x sub initial. The initial velocity times time, 1/2 at squared. What are we solving for? Again, the unknown is the time. Plug in your values now. Let's see what happens. We have 0, the final position, minus 30.4 was the initial position. Followed by negative 8.45, that's the initial velocity, times time, plus 1/2, negative 9.80 t squared. Everybody, when you go to the next line, this is the equation you have now. What's wrong with it? If this side was equal to 0, you can simply factor out the time and solve for it. But what's the issue right now? You rearrange everything and equate it equal to 0. Now you have a quadratic equation. Quadratic equation means a t squared plus bt plus c. In mathematics, you solve this in the form ax squared plus bx plus c equal to 0. But this time we're using the variable time. Again, what kind of equation is this? This is called quadratic equation. How do you solve a quadratic equation? By applying the quadratic formula. What is the quadratic formula? Remember this equation, negative b plus or minus square root of b squared minus 4ac divided by 2a, where a is the coefficient in front of t squared, we have 4.9. b is the coefficient in front of t, which is 8.45. And finally, c is that constant. In my case, what is my constant? Negative 30. Once you solve all of these, you're basically solving for time. And you see here plus and minus. This will give you two conditions for time because after all, you have a quadratic formula, quadratic equation. And you're going to be choosing the one that is positive. Okay, get to work. The whole point of the problem is to review the quadratic formula. The whole purpose of solving the problem is to review the quadratic formula. Okay, this is the end of question number 1 and question number 2.